At an Oregon fiber manufacturing facility, an analyst estimates that the weekly number of pounds of acetate fibers that can be produced is given by the function z equals f of x comma y, where z equals the weekly number of pounds of acetate fiber, x equals the number of skilled workers at the plant, and y equals the number of unskilled workers at the plant. We have several questions here. The first question asks us to find the weekly number of pounds of fiber that can be produced with 11 skilled workers and 36 unskilled workers. So for this question, we want to evaluate the given function when x equals 11 and y equals 36. So we'd have f of 11 comma 36 equals 12,500 times 11 plus 4,000 times 36 plus 7 times 11 squared times 36 minus 5 times 11 cubed. To save some time, I've already evaluated this. It comes out to 305,337. And this would be the number of weekly pounds, given the plant has 11 skilled workers and 36 unskilled workers. Next, we're asked to find an expression for the rate of change of the output with respect to the number of skilled workers. Remember, the number of skilled workers is equal to x, which means you want to find the partial derivative of f with respect to x. To do this, we'll differentiate with respect to x, treating y as a constant. So the partial derivative of f with respect to x would be equal to, well, the derivative of 12,500x with respect to x would be 12,500 plus the derivative of 4,000y with respect to x would be 0, again because we're treating y as a constant, plus the derivative of 7x squared y with respect to x, we would multiply by 2, that would give us 14, subtract 1 from the exponent on x, so we'd have 14xy. And the derivative of negative 5x to the third with respect to x would be negative 15x squared, so we have minus 15x squared. Number 3, we want to find the rate of change of the output with respect to skilled workers when 11 skilled workers and 36 unskilled workers are employed. Because we're trying to find the rate of change of the output with respect to skilled workers or with respect to x, we want to evaluate the partial derivative with respect to x when x equals 11 and y equals 36. So the partial with respect to x at 11 comma 36 would be equal to 12,500 plus 14 times x, which is 11, times y, which is 36, minus 15 times x squared, which would be 11 squared. And again, I've already determined this amount. It comes out to 16,229. And the units on this would be weekly pounds per skilled worker. And because this is the rate of change of the output with respect to skilled workers, the units would be weekly pounds per skilled worker. Next, we're asked to find an expression for the rate of change of the output with respect to the number of unskilled workers. And again, because y equals the number of unskilled workers, we now want to find the partial derivative of f with respect to y. To do this, we'll differentiate with respect to y, treating x as a constant. So the partial with respect to y would be equal to the derivative of this first term with respect to y would be 0, because we're treating x as a constant. The derivative of 4,000 y with respect to y would be 4,000. The derivative of 7x squared y with respect to y would be 7x squared, because the derivative of y equals 1. And the derivative of negative 5x cubed with respect to y would be 0. So here's our partial with respect to y. In our last question, we're asked to find the rate of change of the output with respect to unskilled workers when 11 skilled workers and 36 unskilled workers are employed. So because we're measuring the change in output with respect to the unskilled workers now, we want to evaluate the partial derivative with respect to y when x equals 11 and y equals 36. So the partial with respect to y at 11 comma 36 is equal to 4,000 plus 7 times x squared, but x is 11, so 11 squared. Again, I've already determined this value comes out to 4,847. And because this measures the change in output with respect to unskilled workers, the units would be weekly pounds per unskilled worker. So I think this problem is a nice application of why partial derivatives are useful. I hope you found this helpful.